talk about physics, I don't care. What are quantum computers?
Yeah, you!
What exactly is a computer?
Let me tell you.
A computer is something that computes. In other words, it does math very well.
So how do they work?
Let me tell you.
Go.
Well, the computer works by a series of bits. Okay, so this is 1 bit, and a bit consists of a transistor, just like something like this. Okay, and now this thing is basically a tiny electrical switch, right? It's like very small. It's a magnifying glass. And then now this transistor can be in a state of on, which is 1, or off, which is 0. And that's a bit.
Yeah, you!
So what exactly is a bit used for?
I will let you know.
A bit is used for different things. Okay, so a bit can be either a 1 or a 0, but if you have a lot of these bits, it becomes a unique string, right? Well, not unique, but a string that can be repeated and interpreted in the same way by the components in your computer.
Just keep going. Just keep rolling through it.
And
Oopsie!
So I've heard about quantum computers. What's so special about them?
I'll let you know. What's so special about quantum computers? So while computers run on bits, which are zeros and ones, right? So bits are zeros or ones. What's special about quantum computers is they run on something called a qubit, right? And qubits are both zeros and ones at the same time, right? And this uses properties of quantum mechanics to do computations on really massive data sets. So what we can do here, right, is if we have zeros and 1 bits, say we have 4 bits, 2 bits is easier. So that can either be 0 and 0, 0 and 1, 1 and 0, or 1 and 1, okay? It can only be one of these options. For the sake of argument, we'll say it's 0 and 1. This is what our 2 bits represent. This is the data we represent. What's cool about qubits, though, is it's not just one of those things. Qubits really represent all of these at the same time, right? So what this does is this scales the computational power of a quantum computer exponentially. So this scales to the n, where n is the number of qubits, right? And this only scales normally, so where n is equal to the number of bits. So this only scales 1 to 1, whereas this one scales exponentially. So you have a massive amount of power contained in a very small amount of qubits.
So what does this have to do with physics?
So the issue comes in when you have to observe this, right? The problem with quantum mechanics is it's only in this in-between state until you observe it. Once it observes, it either collapses to a 0 or a 1. we'll say it collapses into a 1. Okay, that's it.
So, how are quantum computers applied in real life?
Let me tell ya.
One major use for quantum computers is decryption. And the way that encryption works is that you take two really big prime numbers and you multiply them together. And in order for someone to get past this encryption, you need to know the prime numbers. And quantum computers are really good at getting those numbers.